Hello, Kirtana. I'm audible. Hello, Kirtana. I'm audible.
Yes,
Okay, Kirtana. Yeah, so Kirtana, in the last session, we completed the whole of your thermal effect of currents. Okay. Do you have any kind of issue, any doubt which you want to clarify before moving to the next? Kirtana, anything you
the
want to
answer for the last question.
yeah, solution to the last one. What will you do? What was the Kirtana problem? What is the problem, Kirtana? Last one. Yeah, Kirtana, what is the problem?
There is a circuit for 6 ohm and 4 ohm.
6 ohm. I think I'm just making circle. Let me know if it is a problem. Let's see. Was it the circuit? Is it the same?
Yes, sir. There is the answer 6.6.
6.6. Yes, sir. Yeah. So this is 6.6. All right. If you got the correct answer, then you can. Yeah. For this one, answer is 6.6. This one, answer for this one is 6.66, or can be written as 20. All right, Kirtan, if you don't have any doubt, so yeah, we can move to the next topic. Okay? Basically, the topic we are going to discuss is RC circuit. Okay? Till now, you have studied about the circuits which either contain resistance, okay? And in the electrostatic, we have studied about which either contain capacitance, right? Now we will try to discuss how actually the circuit will react if both are contained. Okay. Before moving to this, Kirtan, just assume this is a circuit. Okay? This is a capacitance having C is equals to 4 microfarad, okay? And this is a resistance R, and this is a voltage. This is 10. This is 10 ohm. So Kirtana, tell me what will the current passing through this capacitor? What is the current passing in this circuit? Or in simple word, I want you to say that this is I1, okay, this is I2, and this circuit is kept for a very long time, like battery is there. It is kept for a long time. After a very long time, I'm asking what is the value of I1 and what is the value of I2? Can you figure out? If yes, then we'll move to the like this RC circuit part. Yeah, kids. So let's try this one. It's an easy problem, but still I'm giving you 3 minutes. You can think of it and get me. Yeah, Ketan, try to solve this. Get me the answer, please.
I1 is 40,
I1 is
40 and I2 is 1.
right. I don't hear you. Yeah, I have asked you two values, right? First is I1, another is I2, right?
I1
So
is
what are the so, like I1 is in this circuit and I1 is this branch, right? Like I2 is in this branch, I I1 is in this branch. Okay. So what do you think? What should be the ideal value for these two?
40 and 1.
What is I1?
40.
40. Okay. I don't know how, but what about I2? Wait, now what is I2?
1.
Okay. I2 is fine, Ketna. I2 is fine. What is the potential across these 2 points and these 2 points? Okay, Kitna. What do you think in steady state, is there any current flowing capacitor? Is there any current flowing capacitor? What do you think, Kitna? let's say, like, what is the main crux of the current? The crux is, for example, Kate, like here you have one capacitor right now, this is uncharged, okay? And this is a voltage, right? I can simply say, because even if you take it or not, because the potential across this is the 10 itself, okay? So what you can see is here, currently, here the potential is zero. Across this, the potential is zero. Although there is a potential, but energy stored is zero, right? So what will happen by the time, because charges are flowing, there will be a time when accumulated charge accumulation, the potential will be such that potential bit across these two terminals will also be like, if it is 10 now, here also, here it will be positive charges, here it will be negative charges, which will make the 10. So why will be there the current flow if both have a same potential? This thing has the same potential, this battery has the same potential, then why there will be current flow after some time? In a very start, okay, in very start, when this capacitor is uncharged, right now, if I ask you about this situation, if I ask you, let's say this is 10 volt, right, and this is uncharged, what will happen? Small amount of charges will start to flow. If this is positive, you can say here it is negative converting effect. Okay. So if you see, when you don't had any charge, when at time t is equals to zero, when at q was zero, at time t is equal to some time t, what is the charge? Maybe q. So if I ask the potential at that point, I'm not asking potential across these two, what is the net potential? No, I'm asking what is the potential stored in this capacitor. So you can say that Q by C, right? Here it is zero, so it will be zero, but here it is Q by C, right? And this is increasing. By the time you are going, it is increasing. So what is the maximum possibility? Maximum possibility is that charges will only flow until unless its potential across these two terminals, and you can see potential is increasing. So there will be a time where the potential across this and potential across this will remain same. Okay, understood? And what will be the, you can say, in that case, that will be the maximum charge which you can collect on a capacitor. Is this clear to you now?
Yes.
So I said in the given problem, I said this thing was there for a very long time. So for a very long time, mean to say, this must have been reached to steady state. If the capacitor has been reached to steady state, mean to say, there will be no charge flow. Why there's no charge flow? Because it has positive charge, it has negative charge. This is acting as a battery itself. Okay, 10 volt battery. So here is also 10 volt battery. So you can say why will be current flow? Why it like current always flows from higher potential to lower. Here also 10, here also is 10. So it can go here, it can go in this region because this side you will get zero, but there is no point in going this side, right? Kirtana, please let me know, do you have any doubt in this topic, the capacity topic?
No, sir.
No doubt, right?
No, sir.
Oh, fine. Okay. So we can discuss about the charging of capacity. Okay, so Kirtana, what we can say that assume we are given a capacitor connected with a battery, and that's a switch. Okay? So Kirtana, we are very sure that the moment I close the switch, what will happen? From this positive plate, and this is negative. So from positive plate, charges will start flow, right? You can say positive charges are going to go in this way. It will be from this way, right?
Yes, sir.
Okay. Another in another way, what we can see it now, because this is a positive plate, you can call it as switch. How this thing actually works, I'll explain in detail. Basically, Kirtana, you know what? We don't have protons which can flow, right? Only electrons are there who can flow. So, by looking at this positive charge, electron at this positive plate moves out, right? And you know, if from some plate, if some electron came out, this will become positive, right? So this is the same happens. The moment this q electron comes out from here, this plate becomes positive. Okay, understood? So this is actually what happens. And yeah, from here electrons will go to here. It will become an excess. It will become a yeah, what I can say lesser. Okay? It will this plate will have a lesser charge electrons. It will have a more electrons. That will make up a q of a charge.
Yes, sir.
So yeah, here now you know that at very start because at time is equals to zero. What is the potential? What is the charge at my capacitor? You will call it as Z, right? If I ask you, you very well know that formula is Q is equals to C, DC, okay? So by here I can say that potential across capacitor is how much? Zero. Can I say this?
Yes.
Okay. After some time, uh, okay, let's try to maintain a graph, okay, along with it. So this is a charge and this is the time, okay? Basically charge on the capacitor and time. This is what we are going to do. So generally what happens here, you know, at very start, if you see my charge is zero, right? I'll be here. But the moment you close the switch now, for a very sudden, this charge goes at a very higher, basically maximum value, and after that it stays constant. Stays constant mean to say now there is no change in charge. It means current in this particular branch goes to zero. Okay, this is basically very short period of time, very short period of time. Understood the point? very short period of time. What is this time? The time required to charge the capacitor from zero value to some maximum value. And what is the maximum value, Kirtana? The maximum, if I ask you, in this case, what can be the maximum? You know that charge is nothing but whatever the net potential. The net maximum potential it can have is V. So this is the maximum value it can have. So we can say VC. Okay. Is this clear?
Yes, sir.
Okay. Okay. And this basically this moment duration, this duration is can be called as transient period. Okay. Understood? So, in between this transient period, your capacitor is getting charged. After this reason, it is in a steady state. Okay, this is a steady state. If you see Kirtana, this is nothing but graph of charge versus time, right? Q by T. And what is the current? Current is nothing but Q by T. So can I say that the slope of Q by T, Q versus T, will give you the current? So if you see in this case, you have some positive value of slope. From here, you are going to get a positive current. In this region, the slope is zero, is equals to I. Okay. And here you have some value in this region. Is this clear?
Yes, sir.
Okay. Now we will discuss a little bit more by including a resistor along with it. Okay. So now assume that I have a resistor and there's a capacitor. So this is a resistor and this is a capacitor. So kids, now we have already studied how to make circuits, right? How to make some equations. So we'll be using the same thing. At time t is equals to zero, you switched on, you just close the switch. Okay. So what will be happen? Charge will start growing on the capacitor. Okay? At the time t is equals to zero, charge is zero. After some time, it will grow. How it is going to grow? Assume that at some time t, although I'm talking about very short period of time, from this time zero to this time, transit period t. Okay? We will be working on this because I know after this the charge will be zero. Okay, so at this particular case, you can say current is zero. This circuit is currently is going to be zero. So we mainly going to discuss about this reason. So at a very short period of time t, at any time t, current in circuit is I. So yeah, Kirtan, I can say this is I. Okay? This is at a very any random time. So if I ask you, just create a circuit out of it. So what is I? You can say that I is nothing but change of this divided by time, right? I can say this. Okay, because positive is here, so this will be this charge, this accumulation will be in this case. Okay. Yeah. So now let's consider it. Let's say this is V minus. You are going in the direction of current. It will be I here. Again, you are going from lower to higher. So what is the potential? Potential is basically whatever the charge accumulated divided by C in a negative. This comes out as zero. Any doubt here, Petra?
No, sir.
Let's look at the variables. So can I write this I as dq by dt, R as it is minus Q is equals to Q by C. Okay. And in further case, now what you can write it as, uh, yeah, it will be better. V minus Q by C, V this thing is equals to R dq by dt. Now what I can do is I will take dt one side and this Q thing one side. So this will become um, dq divided by cv minus q. Okay, cv minus q will be this, and at other side, this will be dt times of 1 by rc. This is what we are going to get. Any doubt statement in you? If you need, you can take 2 minutes. Look at all the equations which we have mentioned over here, and let me know if you have any doubt. Please clarify this. Okay. Okay, so just take a moment and let me know if you are clear with this.
Clear, sir.
It's clear, right?
Yes,
Okay.
sir.
Okay. Okay, that's fine. Okay, Kirtana, can you try to integrate this thing? If I ask you to integrate, can you integrate it?
Yes, sir.
Okay, so just try to do it. Okay, Kirtana, I'm integrated. Okay. So look, we have to do the integration of both sides, right? Do you know, Kirtana, how to do integration of this part, this portion? This is easy, I know, but how to do the integration of this part? You can make it easy by taking negative out of, it will become dq by this q minus cv, right? This will be dt divided by rc. Okay, and you have to do the integration. Again, if it seems complicated to you, you can make it as what I can say. What is CV? Okay, let's do on it. What is CV? CV is nothing but the maximum charge possible. So can I call that as Q naught? Maximum charge. Okay. So yeah, this becomes Q minus Q naught. Okay. This is from very start I'm writing. Negative is always there. So yeah, dt by RC. And this is basically integration of a linear and 1 by x dx. This comes out as log of x. Okay. So here the same thing is there. So it will become log of q minus q naught. Here this q is variable, this is a constant value. Okay. From where to where I'm going? I'm going from 0 to some maximum value, maybe q. Let's not keep q. I'm talking to some random value q, so let's make it as it is. Okay. So yeah, here the time is going from 0 to p, so you can call this as t divided by r. Okay. This is something we have to discuss about. So yeah, what I'm going to get is q minus q naught. Okay. Again, the subtraction is there, so whole thing is coming out to be in the negative way, the minus q naught. So if you just resolve it, now there's a negative, so keep this negative this way. If you just again resolve it, what you are going to get is log q naught minus q divided by q naught. Is it? Yes, it is. Let's make it q naught. Makes sense? Does make sense? That does make sense. Minus t by rc. So again, wait, now what you can do is this can be written as 1 minus q by q. Also, because I wanted to remove this log, what I have to keep? E exponential and whole thing at the top. Yeah, now you can see I've got a good equation over here. This will go this side, this will go this side. So it 1 minus e to the power t by rc is equals to q by q naught and plus, you know what I have got? Q is equals to Q naught 1 minus e to the power minus t by x. You know what, Kirtana? This equation is basically a transient equation. Mean to say, if you see carefully, if I keep my time is equals to infinity, if I keep my time is equals to infinity, what does this mean? Mean to say, I have kept this switch closed for a very long time, and for a very long time, what will happen, Kirtana? Because it's charging like what I can say. Charges are accumulating. There will be time the potential goes equal to Q. So at that moment, you can say that the charge is maximum. Here you can see when time goes infinity, the charge is maximum. Okay, T is equals to infinity, Q is equals to Q. This is the case. And if you put T is equals to 0, what you are going to do? Something's power 0, means so 1 minus 0. Okay, so this is a very good equation basically, Kirtan. You can use it in the transient period. Okay, any doubt, Kirtan, till here?
No,
Not bad, right? So if you just look at the graph for this one, what kind of graph you can see? The graph is basically exponential, right? It looks like this. And there is a certain time it goes like this, and it is a saturated. Okay. So time Q. And what is the point where it gets saturated? Q is equal to C. Okay. This is okay. Understood? And this is basically the transient period. Transient means to say from minimum to maximum. Okay, time taken to reach minimum value to maximum value. Understood?
yes,
Okay, one more thing is, now, if I ask you, I wanted this process to be very slow. We need to say I wanted this process to be slow. What I should do, ideally, process to be slow mean to say to reach this value, I need more time to be taken. So what I can do is, kids, you can say that yeah, wait. If I increase, like if you see, what is the main crux? The main crux is charging this circuit, right? Yeah, the main crux was charging this capacitor, right? So if you see carefully, what I am doing, if I increase my current in this circuit, basically, if you have more current in the circuit, and if you have more current in the circuit, this capacitor will charge fastly, right? If you have less current, it will charge like very slowly. Okay. So to do this, what you can do is you can just increase the value of resistance again, because I is somehow this I is somehow inversely proportional to the resistance. Okay, that's it. So I'll just remove it and move to the next. So to slow down the process, to slow down, okay, to increase transient period, what is the time t? Uh, yeah, can increase R. Okay. And one more thing is, if you see any circuit which has a very like group of resistors and one capacitor is there, let's say this is a group of capacitors and this is capacitor. So here in this formula which I have put, you don't have to worry about which capacitor I am supposed to put. Simply take the R equivalent of this group of resistors and put it over here. Okay, understood? This is what you can simply do.
yes,
Okay. Transient, increase the transient period, increase the resistance. Okay. Understood, Krishna? Any doubt?
no, sir.
Okay, no doubt, right? Okay, Krishna. So this is the transient thing which we have studied today. I think in the next class we'll discuss about some problem and all. Uh, yeah, I think look at the equation. Let's take out the time in the equation. 1 minus e to the power minus p by r. So, Kirtna, if I say that, what is this RC? RC, you can call it as tau. Okay, tau. What is it? You can call it as a time constant. Time constant. So, when your time is equals to time constant, when t is equals to time constant, meaning to say RC, then what is going to happen? Q is equals to Q naught 1 minus e to the power minus t by t. Okay? You can say that as Q naught 1 minus 1 by e. So what this comes out as, this will come out as 0.637 times of Q naught. It means to say when your time reaches from 0 to RC value, this RC value, in that case, so this thing is going to get charged by 0.637% of the total value. Is this clear?
Yes, sir.
So I just very simple problem. Time taken by time taken to charge capacitor by 50%. Okay, so I'm just solving this problem along with it. So the question says is 50%. What does this mean? That total charge is Q naught. Then what should be my current, like what should be my value of the charge? Like how much my capacitor should be charged? Q naught by 2. Okay, this is what I'm saying. I know the formula, that is solution. Q is equals to Q naught 1 minus E t by. This is tau. Okay, now you can substitute tau because I have given the value. So what is Q? Q naught by is equals to Q naught, cancel, cancel, 1 minus e to the power t by tau. And what is the tau? R. See, sometimes look into some problem you will be given R and C, you have to calculate tau and you can use it. In some problem, instead of giving R and C, they will give you the tau value. Okay? So that's why I had told you about this value. So half is equals to 1 minus t by tau. So what is the value? This is equals to half, and yeah, so just put the values. What I can say is log of minus t by tau, e as it is, it will be removed from here. Yeah, so basically 1 by 2. So log of 1 by 2 is equals to minus t by tau. Okay, log of this. This is e to the base. Yeah. So what you can rewrite the same thing as, it can be written as minus log of t is equals to minus t by tau. Cancel, cancel. So what is the t? T is equals to tau times of log e. If the value of tau is given, you can put it. Otherwise, we all know that tau is nothing but RNC. So if RNC is given, you can also solve the problem. Is that clear, Kirtana?
Yes, sir.
Is it clear? Okay, if this is clear, then yeah, Kirtana, that's all for the today's class. Okay, if you have any doubt, please let me know, or else we can end the session like this. No doubt, Kirtana?
No,
All right, Kirtana. So yeah, you can like you can leave.